So we continue from where we had stopped last time. We were looking at applications of matrices, and we were able to look at how to solve simultaneous equations. So today we want to look at the next one, which is called analysis of demand and supply. Analysis of demand and supply. Analysis of demand and supply. Now, in the analysis of demand and supply, as you can see in the notes which I had sent, the equations are used, or the matrices are used to help us to get what we call the equilibrium point. And equilibrium point is simply the point at which demand is equal to supply. So we are going to illustrate that using the question of December 2014, question 1C, the question of December 2014, question number 1C, December 2014, question 1C. And the question says, it is there in the handout, not in the past papers. The demand and supply functions for products A and B are given as follows. So we have product A and product B for demand and supply. Now, using matrix algebra, determine the equilibrium prices and quantities of products A and B. So when you're told to do so, the first thing is to say at equilibrium points, demand is always equal to supply. At equilibrium point, demand is equal to supply. Now, in this case, if you start with the product A, demand is 1500. So 1500 minus 4QA minus 3QB, it should give us 400 plus 3QA plus QB. That is how the equations should appear. So putting items together, I will be left with this minus 4QA, then this minus 3QA when it crosses over to this other side, then minus 3QB minus QB to be equal to this 400 minus 1500 when I put the right terms together. And in so doing, this adds up as minus 7QA minus 4QB is equals to minus 1100. And this one, we call it equation number 1. That one, we call it equation number 1. Then we come and do the same thing with product B. Product B. Now, product B, we are told 700 minus QA minus 2QB should be equal to 200 plus QA plus QB. QA plus QB. So putting like terms together, I have minus QA minus QA again, then minus 2QB minus QB is equals to 200 minus 700 minus 700. And in so doing, I'm left with minus 2QA minus 3QB being equal to minus 500. And that becomes my equation number 2. That becomes my equation number 2. That becomes my equation number 2. So if that becomes my equation number 2, I can proceed on. And attempt to create matrices. So matrices, we said when you are creating matrices, you pick these coefficients. So this will be minus 7, minus 4. Then we have minus 2, minus 2, and minus 3. Now this is times QA and QB. QA and QB. And this will be equal to, we come to multiply here, or we come to have this one minus 1100 and minus 700.
Sorry, Mwalimu.
Yes.
I'm asking for the second product.
You're asking?
For the second product, when you were getting the equation.
Yes.
You subtracted the minus 2QB. Oh, this other one is QB. Okay, sorry. I thought it was 9 and I was wondering from where. Okay, thanks.
So if that is the clear, then on solving, we say this will come in to be QA and QB equals, you now take this minus 7, minus 2, minus 4, minus 3. You raised power minus 1. Multiply by minus 1100 minus 700. From there, we said you get the determinant. The determinant of this will be minus 7 times minus 3. Minus, into brackets, minus 2 times minus 4. If you consult your calc, you say minus 7 times minus 3 minus 2 times minus 4. The answer I'm getting is 13. Getting 13. Then you proceed and seek to get the new matrix. The new matrix, we said what you do, you interchange these major diagonal elements in terms of their positions, so that this is minus 3 and this is minus 7. And then these minor diagonal elements, you change their signs. So this remains as 2 and this remains as 4. That way. And with that now, you can proceed on and say QA, QB should be arrived at as, my camera is not capturing that. So let me grab here. So QA and QB should be arrived at as 1 out of the determinant, so 1 out of 13, multiplied by the new matrix. The new matrix is -3, this is 4, we have 2, and we have -7. You multiply by the other matrix there, -1100, -700. That way. So in multiplying matrices, we will then proceed and say QA and QB should be equal to 1 out of 13. I hope you remember what we said about multiplication. We take this row, multiply by this column. So it's going to be -3 times -1100 plus 4 times -700. Then 2 times -1100 plus -7 times -700. So this proceeds on to become QA, QB is equal to 1 out of 13. So if I consult my calc, it will tell me that -3 times -1100 plus 4 times -700. I'm getting 500. Then if I again say 2 times -1100 plus -7 times -700, getting 2700. I don't know whether there is any where I went wrong. I was not expecting figures that have decimals. Yeah, I went wrong here. This one should have been, I should have ended with that. If you check your equation, the equation number 2. Equation number 2 on this side, I think it should have been -200 minus 700. I should have ended up with -500. So if that is true, let me first of all change. We see whether that is the case. Can you confirm where we developed equation number 2, whether that is what we should have ended up with? So if that is what we should have ended up with, then this is what I need to have, -500 here and -500, because I'm expecting a value that does not have decimals. So I should say -3 times -1100 plus 4 times -500. Yeah, I'm getting 1300 here. And then 2 times -1100 plus -7 times -500 is also 1300. So that means this is 100 and this is 100. So go back wherever we have had 500, 700 to answer upper. So this one make it to be 500. This one make it to be 500. Make it to be 500. This one, make it to be 500. And that equation number 2, which we had, it should have 500. That equation number 2, yeah, I can see Irene and make the correction, was given as the correction. Yeah, so thus QA is 100 and QB is also 100. So that is how you solve or you analyze demand and supply. So I think we are okay with that. Now, if we are okay with that, I wish to proceed to the next application, which is called input-output analysis. Input-output analysis. And input-output analysis is simply a study of how input-output analysis. Input-output analysis. Now, this one is also known as Leontief's analysis. Leontief's analysis. And this is simply a study. The Leontief's analysis is simply a study that shows how various sectors in an economy depend on each other. And I think I will better, because the notes are there, I will be in a better position explaining when we are having the table. I will explain everything when we have the table. Now, I want to go to question number 1 of June 2006, question number 2. You look at that question of June 2006, question number 2. The question says that an economy consists of 3 sectors whose flow of inputs and outputs is as follows. So we have 3 sectors, and I want us to use that table to explain whatever is required. So we are going to draw something known as transactions table. Transactions table. That question is not there. It is in the handout that I've sent. And in this transactions table, we have a column called details. So as you can see, we have a sector that is called agriculture. Agriculture. We have another one that is called mining. We have another one that is called manufacturing. Manufacturing. Then we will have another one that we call secondary. We have another one that we call primary. And we have another one that we shall call total. So here I have agriculture. I have mining. I have manufacturing. Manufacturing. Then I have final consumer or final demand. Final demand. And then I have something called total output. Total output. So these ones, they are called producer. Producer stroke output. And these ones are called the user stroke the input. Then these ones are called inputs. Inputs. So as you can see in the question, agriculture is given 20,000 here. Mining is given 30,000. This is given 40,000. This is that 2,500. This is 65,000. This is that 2,500. This is that 7,500. This is that 7,500. This 12,500. Final demand is 10,000. This is 30,000. And this is 40,000. So I want you, ukifika hapo, those who are online, you type finished. Type the word finished so that I'm able to proceed from there. So only 2 people have finished. Okay. The others can be joining us as we go by and by. Now, as I've said, input-output analysis looks at how various sectors in an economy interdepend. And when you look at any economy, including the one we have of our own Kenyan economy, we have various sectors. We have the sector that is called agriculture. We have another sector that is called education. We have another sector called transport, and so on and so on. So input-output analysis tries to check how do these sectors influence each other. And the influence is specifically in 2 areas. 1, where do the sectors get their input for them to produce what they produce? Like now that I'm in education sector, what is supporting me for me to be able to do what I'm doing? Someone who is in agriculture, what is supporting that person so that they're able to do farming? Number 2, the output. Once I teach you people, where do you go to work? Who uses my output? When the farmer has done farming and they get the harvest, where does it go? When a doctor has done his work and the patient is well, where do they go? So the relationship is specifically knowing where we get the inputs from and how our output is used. Now, in this case, we have 2 ways of presenting this table. The first way is what you can clearly see here. It is when we use the totals. It is when we use the totals, as you can see. The second way is what we shall be doing in a while. When instead of using the totals, you express in terms of ratios, in terms of 1. Now we explain how to go about that. Now, when you are interpreting this table, this matrix, the square matrix, agriculture, mining, manufacturing, this one, it shows what we call the intermediate demand. It is called intersectoral demand. It is the demand of the output from these sectors that is used by the same sectors for the sectors to produce more. And this matrix here is represented by A. Then this one here, it is called final demand. It is part of the output of this sector, which is used by other users who are not part of the production cycle. And then here we have the total output. Now this final demand is usually represented by matrix X. And this one is represented by, this is presented by matrix Y, and this is represented by matrix X. Now, if you want to know the total output, the formula for the total output, let me adjust my camera upwards. If you want to know down there, utaandika X, or rather, hivi down below the table, when figures are in totals, X is equal to A plus Y. X is equal to A plus Y. So let's start with agriculture. when you come to agriculture, if you want to know the total output of agriculture, you will take the 20,000 plus that 2,500 plus that 7,500. Now these ones, they represent our A. That is our A. Then you add this one, 10, which is our Y. And when you quickly do that, you are able to find 20 plus that 2.5 plus that 7.5 plus 10 is 100. Sasa unakuja hapa unaandika 100,000. 100,000. When we come to mining, we do the same thing. So I will say it is 30,000 plus 65,000 plus that 7,500. Then I add 30,000. Then I add 30,000. So that will be 30 plus 65 plus that 7.5 plus 30 equals 162,500. So that is how we arrive at that, 162,500. And I argue the same way here for the manufacturing. My space is over, I will not write that. So I will say 40 plus that 2.5 plus 12.5 plus 40 is equal to 125. So nimesema hii, it is our matrix A. It is called the intermediate or the intersectoral demand. This one is called the final demand, matrix Y. Maybe you can even come here in your table and try to squeeze. This is matrix A, and this is matrix Y, wherever you can be able to squeeze. And this is X, you are able to squeeze. So this means if you are given any two of these three, you can always get the third one. Naona hii swali ilikuwa imetupea A na Y. So tumeweza kupata what? X. So kama umepewa X na Y, can you get A? Yes. Na kama umepewa A na X, can you get Y? Yes. And make sure you follow. This question is a bit detailed, so we may not be able to do another one. But it's very simple. So si hapo tumeelewana? Yeah. Now the other thing is this. When you talk of the input here, if I come back here, you can see we have the inputs, the ones that are called secondary. So these ones that are called secondary, we get them by adding these ones, the column. So if you say 20 plus 30 plus 40 is equals to 90,000. Maybe as I'm working down there, if you have space, you can show. My space is a bit limited because of the reflection that I'm having here. You can show the working so that you don't spend the whole night wondering how the miracle was beaten to get that figure. If you come here, the next one you say that's 2,500. That's my space. That's 2,500 plus 65,000 plus that 2,500 is equal to what? That 2.5 plus 65 plus that 2.5 is 130,000. The same case you say that 7.5 plus that 7.5 plus 12.5 is equal to 87,500. Yeah. So that is how you get the secondary input. The secondary input, you get them by adding these three. Now, in your handout, you will check and find we have some assumptions. And one of the assumptions is this, that there are no economies of scale or no returns to scale. What that means is what we input will exactly be our output. Kama tumeweka 100, we should get out as 100. So there are no returns to scale. We don't lose, we don't gain. The implication of that assumption is that the total output here, this one, should be equal to the total input. So let's copy here. This one is 100,000. This one is 162,500. And this is 125,000. So copy that.
Mwalimu, please repeat that statement.
The statement says there are no returns to scale. Returns to scale, they are the one or is a concept used to represent a situation where if you input, for example, 10 kilos of rice, chances are you get 12. So that has increased. Or chances are you will get 7. Like when you are cooking cabbage, spinach. Kama umeanza na sufuria ikiwa imejaa, by the time they are ready, inakuanga imeshuka huku chini. So imetoka 10 to around 7 or 5. If it is something like rice, ukianza na sufuria ikiwa quarter, by the time that rice is ready, maybe already the sufuria imejaa. That is the simplest way I can use to explain that. But now here we are saying what we input is exactly what we get out. And because this is our output, we know it. It then means this is exactly what we had put in. I hope whoever does that has gotten clear. That's all.
Yes.
Okay, good. Higher. Now, if that is true, down there, still we are doing some workings. Utaandika total input. Total input is equal to secondary input is equal to secondary input plus primary input plus primary input. The secondary input, when you add to the primary, primary is the one that comes out of the production sectors. So if that is true, if we know that this one imepatikana by saying 90 plus something, we got 100. Can you now be able to tell me primary will be what? If we know that this total is secondary plus primary, can we be able to know primary will be what? Like now, the first one, it will be 100,000 minus 90,000. That will give us what? 10,000. So come and put the 10,000 here. So this one, it will be that 500. And this other one, minus 125. Is that 7,500. You can do those workings if you are not, so that you don't forget. Here 162 to minus 130,000. You have to kapata that 2,500. Alafu ingine uandike 125,000 minus 87,500. We are getting. So once again, if the question has given you 2 of these 3, you see these are 3, eh? If the question has given you 2, you can be able to get the third one. So you can see now kama hapa tulikuwa tumepewa secondary na total. So tumeambiwa tafute primary. Another question will give you secondary and primary. You get the total? Or another question will get you total and primary. Will you be able to get secondary? Yeah, they are very, very simple like that. Very, very simple like that. Now, this is a table that is given in terms of whole numbers. Now, I want you to follow this interpretation. I want you to follow this interpretation. And also as part of your workings, you can also make this point. A row shows usage of output. But these things are in your notes, but just make it as a small point there. That will help you. It shows usage of output. And make sure now you follow this. I want us to interpret this. This is agriculture. So when we are going this way, we are talking of the output from agriculture. So 20,000 is the output from agriculture that is used by agriculture so that agriculture can produce 100,000. This that 2,500 is the output from agriculture that is used by mining so that mining can make 162,500. The output of mining. This 37,500 is the output from agriculture that is used by manufacturing so that manufacturing can make 125,000. Let us interpret the second one. Mining. This 30,000 is the output from mining that is used by agriculture so that agriculture can make what? 100,000. 65,000 is the output from mining that is used by mining so that mining can make what? 162,500. This 37,500 is the output from mining that is used by manufacturing so that manufacturing can make what? 125. Now tell me, 40 is the output from manufacturing that is used by agriculture so that agriculture can make 100. That 2,500 is the output from manufacturing that is used by mining so that mining can make 162,500. 12,500 is the output from manufacturing used by manufacturing so that manufacturing can make what? Yes. And the same can be argued like this. Rather, yeah, let me stop with that point. So that is how you interpret what? A row. Let us now interpret a column. So I think column shows input. So again, make sure you follow. If you interpret this column of agriculture, this 20,000 is the input to agriculture that has come from agriculture. 30,000 is the input to agriculture that has come from mining. 40,000 is the input to agriculture that has come from manufacturing. 90,000 is the total input, or is the input in agriculture that has come from other sectors. And 10,000 is the input to agriculture that has come out of these, outside these three sectors. And 100,000 is the total input to agriculture that agriculture has used to produce what? 100. Interpret this one. This is mining. That 2,500 is the input to mining that has come from agriculture. 65 is the input to mining that has come from mining. That 2,500 is the input to mining that has come from manufacturing. 130,000 is the input to mining that has come from the three sectors. That 2,500 is the input to mining that has come outside the sectors, agriculture, mining, and manufacturing. Similarly, that 7,500 is the input to manufacturing that has come from agriculture. That 7 is the input to manufacturing that has come from mining. 12,500 input to manufacturing that has come from manufacturing. 87,500 is the input to manufacturing that has come from the three sectors. And that 7,500 is the input to manufacturing that has come outside these three sectors. And 125,000 is the total input to manufacturing, so that manufacturing was able to produce 125. So those who are online, are we okay with that? You're okay, type yes. Okay. 3 people have responded, so I think I go by that. Now, I've told you there are 2 ways of presenting this table. Particularly this one. This is upper down. Easier. The matrix A. It can be presented either as totals or power 1. Or power 1. But this one will always remain that way. You will get the totals.
Liam, I have.
The one is talking. Christy.
Yes, I have a question.
Uh-huh.
From the interpretation that you have given, how will you interpret the column of final demand?
The final demand is not interpreted, or in simple way, if you want to interpret it, this is what the final consumers have gotten from agriculture, 30 from mining, and 40 from manufacturing. But we do not bother so much with the final consumer, because that guy is not going to do further production, or we are not aware that he will do production. Ours is to concentrate on those who will do production. Is that okay, Christine?
Yes.
Yeah, good. Or in other words, we have said, like now, this 40,000, it is the output from agriculture that went to the final consumer for purposes of not further production. Okay. So kama tumeelewa, now look at it this way so that now we can transit to the ratios. Tumesema this 20,000 is required by agriculture so that agriculture can make 100,000. So how many does agriculture require so that it makes 1? How can you get that? 20 is what agriculture requires so that they make 100. So how many do they require so that they make 1? Yes, Christy, good. It is like this. It is 20, you divide by 100. That is 0. What? 2. Sawa. Haya. So sasa hapa usafiri na mimi ukiangalia, I will tell you when to write. This one is what is required by mining, so that mining can make what? 162. So if you want to know one, it will be that 2.5, you divide by 1, 62.5. The same here, it is required so that we make this one. See, then it will be 37,500, 37.5, I divide by what? 125. Now this one is required by agriculture so that agriculture can make what? 100. So even here I divide what? By 100. Even here I will also come and divide by what? 100. This was 40, eh? So even here I will also divide by 100, eh? And here I divide by 100. And here I divide by 100, itakuwa 1. Tumeelewa hiyo arrangement? So kama tumeelewa, I want us to draw below that, you draw something called technological coefficients matrix. Technological coefficients matrix A. Technological coefficients matrix A. So here we have the producer. I don't know whether my space will be enough. And here I have the user. So if I start with agriculture, let me design, you see how it looks like because of the interest of my space. It is exactly this one that we are copying. So when I come to agriculture, there, tumesema it is 20, we divide by 100, tukapata 0. What? 2. This is 30, we divide by 100, we get 0.3. This is 40, we divide by 100, we get 0. What? 4. That is for agriculture. Haya, tukuja kwa huyu mwingine anaitwa mining. Mining utasema ni that 2.5 you divide by 162.5. Haya, 65 you divide by 162.5. Haya, that 2.5 you divide by 162.5. So that 2.5 divided by 162.5, this is 0.2, this is 0.4, this is 0.2. The last one, the manufacturing. Manufacturing. Manufacturing, we do the same. It will be 37.5 to divide by 125. 37.5 to divide by 125. 12.5 to divide by 125. So 37.5 divided by 125 is 0.3, 0.3, 0.1. That is how you create the technological coefficients matrix. The technological coefficients matrix. So these are the ratios, and sasa here, this one, 0.2, it is what agriculture requires from agriculture so that it can make 1 unit. This is what mining requires from agriculture so that it can make 1 unit. This is what manufacturing requires so that it can make 1 unit. Now, for yourself, for your case, maybe because you have space, ushafunga hivyo, hiyo matrix inakuanga hivyo. But I want us to add a few things below that, but they are not part of the matrix. They are not supposed to be part of the matrix, but in connection with this. So if you come here, unajaribu tu kuipanga kama hii venye iko So uandike input, useme secondary. Secondary. Sasa secondary, the same way tumefanya hapa. So uliona tuliadd this is the same thing we are going to do. This plus this plus this will give us 0.9. And therefore primary will be 0 points, and the total will be what? 1. So I don't have space. The same column. Let's come to mining. We could have for mining, this plus this, that will be 0.8. Therefore, primary must be 0.2. So that when you add the two of them, they give you what? 1. Ukikuja kwa manufacturing, when you add, this is 0.7. So that primary is 0.3 and this is 1.0. Again, this one creates another relationship of threes. Unaona these values, these ones, there are 3 of them. Kuna hii 20, kuna hii 100 na kuna hii 0.2. And the same with others. So if the question has given you 2 of them, like sasa hii swali yetu ilikuwa imetupea 20 na ikatupea 100. So tumetafuta 0.2. So ukiwa na 0.2 na 100, can you get 20? Or ukiwa na 0.2 na 20, can you get this 100? Yes. Now this table, and this is what I want you to get and get so well. It is a relationship of 3 threes. I call it 3 threes. A relationship of 3 threes. The first 3 is this one. Hii ndio nimeexplain. Unaona hiyo iko na 3 items. The next 3 ni hii nilikuwa nimeexplain hapa na ndio bado iko hapa. You see these ones are 3. The secondary, the primary, and the total. And tulisema how you can get, and ndio bado ziko hapa. The third 3 ni hii. Tunakumbuka tulisema a plus y equals x. Yes. So there are 3 threes. There are 3 threes. Sasa Naendelea tu vizuri. Below that now, below this matrix, andika hivi. Ile formula tulikuwa tumeanza nayo ya kwanza huko juu tulikuwa tumesema when given in totals, when figures are in totals. Is that what we say? The very first thing tuliandika below the table. Nisema when figures are in total. Sasa nataka uandike another one. Tuseme when figures are in ratios. When figures are in ratios, like now these ones that I have. When figures are in ratios, this is the formula we use. X is equals to I minus A inverse multiplied by Y. So that is the second formula of getting X. Ile ya kwanza tulikuwa tumesema ni A plus Y, you get X. Sasa hii inamaanisha you get I. I is the identity matrix. You subtract this matrix. Then this one will be a 3 by 3 matrix. And we already know how to get the inverse of a 3 by 3. Yeah. But most of your questions, the examiner will give the matrix. Like now in this one, we already have been given. So if we go back to the question, inasema required. Get the output level for each section if the final demand for agriculture increased by 1,000 and that of manufacturing falls by 500 and that of mining remains, yeah, unchanged. So what that means is that matrix Y, new Y will be, si tulikuwa na ile ya 10,000 E for agriculture. We are told agriculture increased by 1,000. So if I add by 1,000, that would be 11 what? 1,000. Then mining, it is 30,000. We are told mining remained unchanged. So we changed to 0. So that is 30,000. Manufacturing, which was 40,000, we are told it decreased by 500. So I'll say minus 500. So this is 39,500. That is new matrix Y. So this one I don't need it because they already have done the workings for us. Washatupatia the washatupea the, tutaendelea hapo chini useme thus X should be equal to. Sasa uchukue hii Leontief inverse. Hapo kwa table hawajaweka hiyo rate kwa -1. It should be there. So we are going to have 0.48, 0.39, 0.30, now 0.24, 0.60, 0.24, 0.24, 0.33, 0.42. We multiply by this one, which is Y, 11,000, 30,000, 39,500. So I want you to multiply and you give me the answers. After you have multiplied, I would like you to draw another table kama hii, but usiweke figures, but the titles are the same. Alafu kwa hizi cells, hizi tisa, or the cells, don't squeeze them. We will have workings. We will have some workings. Because sasa tutakuwa na hii na hii, tutakuwa tunatafuta 20, na inataka tuzifanyie hapa ndani. So as you draw, usinyonge the cells sana. So get the answer there, draw the table quickly. I told you the question is involving, you must be fast. So you draw the table without the figures. Shapata hapo. Tuendelee. So now through back. So what are the answers? You have no answer. You just drawn. So 0.48 times 11,000 times 30,000 plus 0.24 times 39,500. I think there was something that is missing. This one should have been 0.192. So divide by 0.192. Let me confirm. I think there is something that is missing here. Yeah. Needs to be 1 out of 0.216. So if you already had gotten the answer, you just divide by 0.216. So 0.248 times 11,000 plus 0.24 times 30,000 plus 0.24 times 39,500. You divide by 0.216. Yeah, I'm getting 101,667. If I round up, 0.39 times 11,000 plus 0.6 times 30,000 plus 0.33 times 39,500. You divide by 0.216. It is 163,542. 163, 542, 0.3 times 11,000 plus 0.24 times 30,000 plus 0.42 times 39,500 divided by 0.216. I'm getting 125,417. So I told you to draw a table that is empty. So let's start by recording those values here, the total output. 101,667, 163, 542, 125,417. Then, as we said, those total output will be the total input. So kuja record hapa 101,667, 163, 542, 125,417. The final demand is this one that we had revised here. So hapa tulikuwa tumeweka 11,000. This one was 30,000. And this was 39,500. So nataka unisomee the ratios that we had in matrix A. This one was 0.2. Hapa 0.3. And this one was 0.4. Then here 0.2. Huh?
0.2, or going downwards, that's 0.3.
This one?
Yeah, 0.3. Then 0.4.
Then hapa?
0.4. Then 0.2. Update 0.2.
0.2.
Yeah.
Then here is
0.3.
This is 0.3.
0.3. 0.1.
Good. Sasa, if you remember what we had said, this one, when we added, we got 0.9, and this one is 0.1. Now, what we shall do to get the answers, we shall multiply with this. So here I multiply by 101,667, you get the answer. Multiply by 101,667, get your answer. Multiply by 101,667, get your answer. Multiply by 101,667, get your answer. Multiply by 101,667, you will have the answer. The same case here, this is multiplied by 163, 542, 163,542. 163,542. Then when I add, this is 0.8. I multiply by 163,542. This is 0.2. 163,542. Then here you multiply by 125,417. Multiply by 125,417. 125,417. This is 0.7 multiplied by 125,417. 0.3 multiplied by 125,417. So work out that. So I believe that we are through. So that is how you handle input output. Now, what we have done is everything that you can be asked. So it's not exactly what the examiner wanted. We have done a lot. So I would like you to revise that question. And after you have done all that, you attempt the others two that are there. And that would be fine. So this coming Saturday, I intend us to have a class. I intend that we have a class so that we can do now Markov analysis. So this coming Saturday, we will have a class. Thank you.